Hello guys, welcome to another video. This one is paper 3-1 of May and June 2020 of paper 3. That is A-level paper. Okay, so let's move on to question number 1. So find the set of values of x for which this is less than this. Give your answer in simplified exact form. Okay, so step by step. First, what can we do is we can, since we have 2 times 3 power 2x less than 5x. So when the power is x, you have to apply ln on both sides. Ln, this will be becoming this, right? And then on the right side become ln 5 power x. Now next step, we can separate those two. It will become ln of 2 plus ln of 3, 1 minus 2x. Okay, that's the simplification. Now we can send the power to the front. Power to the front, you will have ln of 2 plus 1 minus 2x times ln of 3 less than x ln of 5. Now let's expand this. You will have ln of 2 plus ln of 3 minus 2x ln of 3 less than x ln of 5. Now let's bring everything to every x to one side. You will have ln of 2 plus ln of 3 less than x ln of 5 plus 2x ln of 3. So this will become ln of 2 times 3, that will be 6, less than, we have to factorize the x, so that will become ln of 5 plus 2 ln of 3. Now if you observe, what is this? So we can send the power on top. This become here. You will have ln of 3 power 2, which is ln of 9. Okay. So now let's rewrite this again. You will have ln of 6 less than x ln of 5 plus ln of 9. Now when you have plus, that is, you have to multiply the inside. You'll have ln of 6 x ln of 5 times 9 will be 45. So in that case, x will be equal to ln of 45 less than x, or you can write this down as x is more than ln of 6 over ln of 45. And that will be your answer for question number 1 in exact simplified form. Now let's move on to question number 2. Expand this in ascending powers of x up to and including the term in x squared. Okay, so step by step, first we have to simplify this, right? You will have 2 minus 3x power minus 2. Now let's take out the 2. That will be 2 outside. You will have 1 minus 3 over 2 x power 2. Sorry, it's minus 2. Now simplify, let's bring this one in. You will have 2 power minus 2 times this 2x power minus 2. Now this is equal to 1 over 4 times 1 minus 3 over 2x power minus 2. Now we can simplify this. So let's write down the normal form of this expansion. So basically, for example, if you were to expand 1 plus, for example, if you were to expand this power n, you should be having 1 plus n times x plus n times n minus 1 x squared divided by 2 factorial plus minus 1 minus 2 x cubed divided by 3 factorial, and it keeps going on. But now we only need the term in x squared. We have to stop right here, right? Now for this one, the value of n should be what? N should be minus 2, and the value of x should be minus 3 over 2x. Now we just have to replace those back in this expansion to find the required values. So let's do that. So we have 1 over 4 outside multiplied by 1 minus 3 over 2 minus 2. That will be 1 over 4 times, we have 1 plus n is minus 2, times x will be minus 3 over 2 x plus n again, that will be minus 2 times minus 3 times minus 3 over 2 square divided by 2 factorial, which is 2. So we forgot the x here, so let's put x in here. So we only have to expand until here because we're only interested until determine x squared. So now we just have to simplify. That will be 1 over 4 times 1. That will become plus 3x. That will become, this is 2, goes away. That will be plus 3, so plus 3. That will become 3 times 9 over 4x squared. That will be plus 27 over 4x squared. Now we have to expand. You will have 1 over 4 plus 3 over 4x plus 27 over 16x squared. Okay, that will be your expansion until determine x squared. Now for part B, state the set of values of x for which it is valid. So for that we have to look at this value of x. Sorry, this value of x. So we have to know that for this to be valid, x has to be between minus 1 and 1. But now here x, as you can see, x is equal to this. Replace this by this. That will be minus 1, and that will be minus 3 over 2x. Now make x the subject of formula. You will find that it will become minus 2. That will become x. That will become minus 2 over 3 less than x, 2 over 3. So that could be your answer. You can leave this as your answer, but if you want to rewrite this again, you can also do factorial, so not factorial. Modulus of x is less than 2 over 3, which is the same as this. Okay, so that will be your answer for part B, and that is your question number 2. Now let's move on to question number 3. Okay, so we have to express the equation, this as a quadratic equation in terms of tan theta, and hence solve for this domain of theta. So to simplify this, we have to use your formula. This will be given to you on the formula sheet, but it is always best to know this by heart, I would say. So this is the usual formula that is given to you. So you have to use that to replace those values in the equation. Okay, so they will be something like this. Okay, so basically the first one is tan theta plus 60. That will be, first one is a, this is b, this is plus, so we have to use plus. It will be tan of theta plus tan of 60 over 1 has to be minus tan of theta and tan of 60. Now what is tan of 60? We can verify. So tan of 60, that should be, that is same as root 3. Okay, sorry, it should be root 3. Okay, so let's replace. You will have tan of theta plus root 3 over 1 minus root 3 tan of theta. That is your the first part of the equation. Now how about this one? So I'll use a different color for this one. So tan of 60 minus theta. That will be tan of 60 minus tan of theta divided by 1 plus tan of 60 and tan of theta. That should be root 3 minus tan of theta divided by 1 plus root 3 tan of theta. So now once you have these two terms, you have to replace back in the equations. Okay, so on one side you will have this thing. You will have tan of theta plus root 3 over 1 minus root 3 tan of theta is equal to 2 plus root 3 minus tan of theta over 1 plus root 3 tan of theta. Now we can send this one over here. So send this over here. You will have tan of theta plus root 3 over 1 minus root 3 tan of theta. That's the left hand side. Now when we send this over here, become minus, let's put a bracket to be safe, over 1 plus root 3 tan of theta equal to 2. Now we have to simplify this part. As you can see, they have different bases, so we have to find the LCM. So to find the LCM, we have to multiply by each other. Become 1 minus root 3 tan of theta times 1 plus root 3 tan of theta. Then we have to cross multiply. So on this side you will have tan of theta plus root 3 times this one, 1 plus root 3 tan of theta. And then for this side you will have minus root 3 minus tan of theta times 1 minus root 3 of tan theta. That is equal to 2. So let's simplify one by one. So what is this going to be equal to? So let's do this on the side. 1 minus root 3 times this. It is equal to 1 square minus 3 tan square, which is 1 minus 3 tan square. That's the base. How about the top? The top should become, let's simplify, so expand, you will have tan of theta plus root 3 tan square of theta plus root 3 plus 3 tan of theta. Then we have minus here. Okay, you will have first expansion will be root 3. Okay, and then that will be plus tan of theta. Then we have tan theta. So I have put the minus already inside. Let me just remove this for now, because if you put minus here, so minus root 3 times 1 should be minus root 3. Minus become plus. That's the first one, and that will be plus times this should be plus, and then this should be, so it should be plus, that should be minus root 3 tan of theta. Now we have to simplify. Let's see what happens. So these two cancel out, and that should be square. These two cancel out. So you will have, this is tan theta, that will be 8 tan theta. So the top will become 8 tan theta, and the bottom is this one. So let's simplify to see what happens. So you will have 8 tan theta on top, divided by 1 minus 3 tan square theta equal to 2. Now the next step is to cross multiply. You will have 8 tan theta is equal to 2 minus 6 tan square theta. Now let's send everything to one side. You will have, this side you will have 6 tan square theta plus 8 tan theta minus 2 equal to 0. Now let's divide everything by 2. You will have 3 tan square theta plus 4 tan theta minus 1 is equal to 0. Now we have to solve this equation. So let's see if is that possible. So let's use our formula. So let me use that to see if that is possible. So 3 tan theta. So no, it is not factorizable like this, because we have to have plus here and we have minus here, so it's not factorizable like this. You have to use your formula to find this value. So tan of theta is equal to minus b plus minus root of b square, which is 4 square minus 4 times a times c. That should be 28 divided by 6. So for the first value should be tan of theta is equal to what? Minus 4 plus root of 28, 0.215, or it can be minus 4 minus root of 28 divided by 6 minus 1.55. So it is two possible values. Now for the first one, let's solve this one first. So here we have tan theta is equal to 0.215. Now when tan is positive, it has to be in your first quadrant and in your third quadrant. Okay, so this will be, but as you can see here, our domain is only in our first and second quadrant, so only this value will be taken. Okay, so theta will be tan inverse of 0.215. 0.215, that should be 12.1. And how about this one? It should be -1. So tan inverse, tan equal to minus 1.55. Now when tan is negative, it is in your second quadrant and in your fourth quadrant. But here we will only take the second quadrant because, again, theta is between 0 to 180. So theta will be tan inverse. Let's first find the positive value of 1.55 to see what is that value. That will be 57.2. But the value will be what? The value will be 180 minus theta. So your value should be 180 minus 57.2. That'll be 122.8 degrees. So your answer will be two values. One is 12.1 and 122.8 degrees. And that will be your question number 3. Now let's move on to question number 4. So we have a curve with the equation y has a stationary point in this interval. Now part 1 is find the x-coordinate of this point, giving your answer to 2 decimal place. So as you guys must know by now, at stationary point, dy by dx is equal to 0. So you have to first find dy by dx. So dy by dx is equal to what? So this one is a product. We have to use the product rule. So let's write the second term as it is. So we have this. Then multiply by the differentiation of this one. It should be 2e2x. Plus, then we have to write this one as it is. Then multiply by the differentiation of this term. That will be cos x plus minus 3 sin x. So that should give you, if you were to simplify e to x outside, you will have 2 sin x plus 6 cos x. Plus, you have this, and then you have to simplify again, cos x minus 3 sin x. Now let's simplify again. That will be 2 sin x plus 6 cos x plus cos x minus 3 sin x. That will become, so 6 plus 1, that will be 7 cos x, 2 minus 1, 3, should be minus 1 sin x. So that will be your dy by dx. Now we have to equate that to 0 to find the point. Now the first possible value will be this one. So 2x is ln 0, which will be invalid. Because if you check using your calculator, ln 0 is not a valid answer in the real numbers. Now for this one, 7 cos x minus sin x is equal to 0. Now we have to divide by cos x everywhere. You will get 7 minus tan x equal to 0. So tan x is equal to 7. Given that tan is positive, it has to be in your first quadrant and your third quadrant, right? But now as you can see, your answer of x can only be in your first quadrant, so only this value will be counted. X will be tan inverse of 7. We have to have a radians, so tan inverse of 7, 1.7 So we have to provide your answer correct to 2 decimal place, 1.43. X will be 1.43. That is your answer for part A. Now for part 2, determine whether the point is a maximum point or a minimum point. So to find the nature of the point, we have to find d2y and dx2. So since we know dy by dx is this, we can find this the same way. It is a product, we have to use the product rule. So the first, we have to rewrite the second term as it is, and then do dy by dx. You will have 2, and then plus this term as it is, and then same thing, dy by dx for this one. You will have minus 7 sine x minus cos x. Now we can try to factorize again. You will have exponential 2x, that will be 14 minus 2 sine x minus 7 sine x minus cos x. That will become exponential 2x. So 14 minus 1, that should be 13, minus 2 minus 7 minus 9 sine x. So we have this now, so we have to find the nature. So d2y and dx2 at the point where x equal to 1.43. Exponential 2 times 1.43 and 13 cos 1.43 minus 9 sine 1.43. Let's find what is the value for this expansion. So first exponential 2 times 1.43. That will be what? That will be this multiplied by 13 cos 1.43 minus 9 sine 1.43. That should be minus 123.7, which is a negative value. So you can say since d2y by dx2 is negative, the point is a maximum point. Okay, that will be your answer for part B, and that is your question number 4. Now let's move on to question number 5. So find the quotient and the remainder when this is divided by this. So let's do that. So divisions, here we have 2x3 minus x squared plus 6x plus 3. So let's perform a long division. This will be x squared plus 0x plus 3. Now the first question asked is, how can you make this become 2x cubed? You have to multiply by 2, and the next you will have 2x cubed, and then this will be 0 minus 0 x squared, and then plus 6x. This one goes away. Now minus become plus, so minus become the same thing, minus x squared, that will become 0 and plus 3. Now question is, how can you make this become this? Multiply by minus 1, you will have minus x squared plus 0 minus 3. These two goes away, so 3 minus minus becomes 6. That will be your remainder. So basically, let's write down, so your quotient is the one on top, which is this one, 2x minus 1, and the remainder is the one left behind. So that will be your answer for part A. Now let's move on to part B. Using your answer from part A, find the exact value of this integration. So basically, since we know this divided by this, we know the remainder and the quotient, we can rewrite this down in terms of its remainder and its quotient. So this is equal to 3, 1. We have the quotient of 2x minus 1 plus a remainder of 6 over this, right? That will be the equivalent of this one to integrate. Now let's break this down into two parts. Let's do this one first. 3, 1, 2x minus 1 dx, you will have x squared minus x 3, 1. That should be 9 minus 3 minus 1 minus 1. That should be 6 minus 0. That should be 6. So that is the first part of the integration. Now for this one, let's do this separately. So you have integration of 6 over x squared plus 3 dx. Now whenever you have x squared plus a constant, you have to think about the integration of this one. You have to use this one. 1 over 1 plus x squared dx, it is equal to tan inverse of x. This is given to you on your formula as well, on your sheet of formula as well, but it is always good to know whenever you have x squared plus a constant, this doesn't really matter. You have to find something in terms of this. Now, how can you make this become 1? So first thing you can do is you can remove this 6 by taking this outside. You'll have 1 over 3 plus x squared dx. Now what can you do? You can try to simplify this. You will have 6 is outside. Let's take out the value of 3. You take out 3, you will have 1 plus x squared over 3 dx. Now we can simplify this. Now become 2. So you will have 2, and this is equal to 1 over 1 plus, that will become x over root 3 square dx. Now this one is almost similar to this one. What can we do now is we can say let u equal to x over root 3 based on that, right? Now, so to find du by dx, that will be 1 over root 3. So let's make dx the subject of formula. That will become root 3 times du. Now replace this one back in your integration. You have 2 root of 1 over 1 plus u squared dx is equal to root 3 du. Okay, so we have this for now. Now let's simplify. What we can do now is we can take this one out. You will have 2 root 3 integration of 1 plus u squared du. Now this is pretty easy, as you have seen here. 1 plus x squared become this one, so 1 plus u squared will become, so here this is the same, become tan inverse of u. Now the last step is to replace u by your main value, which is x over root 3. So your answer here we have will be 2 root 3 tan inverse over x over root 3. Okay. So now the limits is between 3 and 1. So 3 and 1, let's solve that. So first let's take out this value. So we have tan inverse of 3 over root 3 minus tan inverse of 1 over root 3. Let's see what we get. Tan inverse of 3 over root 3. So this value should be an exact value. Let me see. 3 divided by root 3. Tan inverse of that will be this. Let me use. Oh, this is actually root 3 still. Okay, so tan inverse of root 3. Sorry, root 3. 60 degrees, that is pi by 3. Sorry, pi by 3. That is the first one, and this one should be tan inverse of 1 divided by root 3 should be 30 degrees, which is pi by 6. So now if you want to simplify this, that will give you 2 root 3. That will be pi over 6. Now if you simplify, this will become 1. This will become 3. You have root 3 over 3. This. Now what is this one? So as you know, 3 is just root 3 square. So you can simplify this. That will become root 3 over root 3 square, cancel out, you will have 1 over root 3 pi. Okay, so basically this part become 1 over root 3 pi, and this one is 6. So your answer finally will become 6 plus 1 over root 3. That should be your answer for this question number 5. Okay. Now let's move on to question number 6. The diagram shows a circle with center O and radius R. This is the radius R, okay? Now the tangents to the circle at the points A and B meet at C, so these two has to be the same, okay? Now the angle AOB is 2x. Now something you can do here is you can simply join the points O to T. By doing this, you cut the angle exactly in half. Since this is the same and these two are the same because they are the radius, that will be your angle X and angle X. Okay. Now what's next? The region is bounded by tangents, okay, and the minor arc. The area of the region is equal to the area of the circle. That is the information we need to use to solve the part 1 of this question. Show that x satisfies the equation tan x equal to pi plus x. So we have to use this information. So first thing, very easy. What is area of circle? So let's do that. Area of circle is equal to pi r square. Right? This is just the formula, and this is the radius given to us. Now what is the area of the shaded region? Now if you observe, this area can be broken down into 2 parts. We can find this one first, and then this one is also the same, right? So let's find this one first. Now how would you find this area? Now if you observe, this area can be found by, you can first find the area of the triangle and then minus the area of the sector, so this one will be remaining. So let's do that. So let's first find the area of triangle AOT. So we can use the formula half times base times height, because it is a right angle triangle. We have the base, which is r, and what is the height? AT, we have to find what is the height. The height is AT, and how can you find AT? If you observe, it is a right angle triangle. We can use SOHCAHTOA. So here we have to use tan of the angle, that will be AT divided by the radius. So basically AT will be r times tan x. Now replace back in your equation, so that will be half times base, which is r, times r tan x. That will be r square over 2 tan x. That is the area of the big triangle. Now we have to find the area of the sector, so we can minus that part, right? So area of sector is half r square theta. So half is half, r square is r square, theta is the angle, which is x. So area of A that we want to find is area of triangle, which is r square over 2 tan x minus area of the sector. Now we can just simplify. We can take out half, we can take out r square, you will have tan x minus x on the inside. So that will be your area of A. Now the area of the shaded region is A plus A. So let's write down area of shaded region is 2 times this. That will become, so 2 times this will cancel out. You will have r square tan x minus x. Okay, so now since we have this and we have the circle, we know that these two are equal. So we have to equate them with each other. So on one side you will have this area is tan x is equal to pi r square. R square cancel out. You will have tan x minus x equal to pi. So tan x equal to pi plus x. And this is shown as required. Okay, that will be part A. Now let's move on to part B. This equation has one root in this interval. Verify by calculation that this root lies between this. So as you have seen, we have tan x is equal to pi plus x, which means x is equal to tan inverse of pi plus x. So let's verify with this first value of x equal to 1. So left hand side we say, and right hand side, right? Left hand side we say it is 1, and what is the value for the right hand side? That will be tan. So we have pi, we have to use radians, plus 1. That should be 1.334. So the left hand side is less than the right hand side. Now let's use x equal to 1.4. The left hand side is 1.4, and what is the right hand side? That will be tan inverse of pi plus 1.4. That will be 1.354. As you can see here, we have a change of sign. It means that it is in this range. So since there is a change of sign, between x is equal to 1 and 1.1, it means that it lies, the root lies between 1 and 1.4, sorry. Because of this change of sign, it is validates that it is between those two. That will be part B. Now for part C, use this formula to find the root correct to 2 decimal place. Okay, so the first value of x, you have to choose the one which is exactly in between, which is 1.2. Now let's find x2. So let's do that. So first 1.2 is your answer. That will be tan inverse of pi plus answer. So second value will be 1.3. So we have to provide that to correct to 2 decimal place, right? So we have to give to 4 decimal place. So 1.3444. Now x3. That will be 1.351. So 4 decimal place. So one more. That will be 5. x4 will be 1.3518. x5 will be 1.3518. x6 will be 1.3518. Let's do one more. x7 will be 1.3518. So it confirmed that by doing that, you see that the last 4 iteration give you the same values. It means that the value of x correct to 2 decimal place should be 1.35. That will be part C of that question, number 6. Now let's move on to question number 7. So we have f of x equal to this expression. Now first we have to find f. What is f prime? F prime is just dy by dx. So we have to differentiate this expression. Now you observe that this one is a fraction, so we have to use your quotient rule, right? So f prime of x is equal to, first step is to write the denominator as it is, multiply by the differentiation of this one, should be minus sin x, then minus, we write the numerator as it is, then multiply by the differentiation of the base, should be cos x. Now all this we have to divide by the base square. That will be 1 plus sin x square. Now let's simplify the top first. Here you have, if you bring this in, you will have minus sin x minus sin square x minus cos square x. Now if you simplify, you will have minus sine x. You take out minus 1, you will have sine square x plus cos square x. Simplify again, you will have minus 1, so minus sine x minus 1. This becomes 1, so it is minus sine x minus 1. That is the top of the fraction. So replace this one back in your main equation. You will have minus sine x minus 1 over 1 plus sine x square. So now you have to observe is we can make that become like this, right? If you take out minus 1, you will have 1 plus sine x. That will be over 1 plus sine x square. Now these two are the same, we can cross out. You'll have minus 1 over 1 plus sine x. So now, as you have seen, we have shown that we have f prime of x, which is dy by dx, equal to minus 1 over 1 plus sine x. So now we have to show that it is actually less than 0 for the values of x between this and this. So now one thing you should know is that for any values of, so for most values of x, I would say, sine x is going to be between 1 and minus 1. Now here we have 1 plus sine x. So 1 plus sine x has to be between 2 and 0. So what does that mean? It means that 1 plus sine x is always going to be positive, right? Because it is between 0 and 2. It cannot be negative. So look at your fraction. You can say the numerator is negative, the denominator is always going to be positive. Now negative divided by positive is always going to give you negative, and that is why f prime of x always going to be less than 0. That is the reason why. That is part A of question number 7. Now let's move on to part B. We have to integrate f of x, give your answer in simplified exact form, okay? So that will be half pi 1 over 6 pi f of x is given by cos x over 1 plus sin x dx. So this one we have to solve by substitution. Here we have sine, here we have cos, so we have to use this one. U equal to sin x. So du by dx, that will be cos x. So dx has to be du over cos x. Now replace back in your equation, you will have integration of 1 over 2 and this. So cos x on top, 1 plus sine is u, and dx will be du over cos x. We can cancel those two out, so you have to integrate 1 over 1 plus u du. Now this is pretty simple. It will equal to ln of 1 plus u, right? But now the thing is we have to replace back the value of u by sin x. So you have ln 1 plus sin x, and your limits have to be back the same, which is half of pi and 1/6 of pi. Now we can solve this. We have ln of 1 plus sin of half pi minus ln of 1 plus 1/6 pi. Okay, let's solve one by one. So let's use radians. So 1 plus sine of, so pi over 2, right? That should be 2. Minus sine, so we have 1 plus sine of pi over 6. That should be 1.5. So since you have minus, you have to simplify. It becomes ln of 2 divided by 1.5, which is ln of 4 over 3. And that is your answer for part B of that question. This is question number 7. Now let's move on to question number 8. A certain curve is such that its gradient, so whenever you see gradient, you know it means by dy by dx. At a point x and y is proportional to this one. So basically right now we have this equation. It is proportional to y x times root x. Now, as you know from O-level paper 1, whenever you have proportional, you can rewrite this down as equal to dx equal to a constant of proportionality times this over x root x. Okay, so the curve passes through these 2 points. So we have to use these points to find the value of k, and then later on find the value of c when you integrate to find the equation of your line. So by setting up and solving a differential equation, find the equation of the curve. It means to find y, expressing y in terms of x. So pretty easy. We can send dx over here and y over here. You will have 1 over ky dy is equal to 1 over x root x dx. Now, so if you observe this now, what is root x? It is x power half. That can be written as x 1 plus half. That will be x 3 over 2. So this is equal to 1 over kx dy is equal to 1 over x power 3 over 2 dx. Now again, we can rewrite this down again as, we can take out this multiple. That will be 1 over y dy equal to x minus 3 over 2 dx. So now we have to integrate that to find the value of y in terms of x. So step by step, first this one will become what? Take out 1 over k, you will have ln y is equal to, you have to plus 1 become minus half, divided by minus half plus c. So this will give you what? 1 over k ln y is equal to, that will be minus 2 divided by root of x plus c. Now for now, this is the equation of the curve. We have to find the values of c and find the value of k using those 2 points. 1, 1 and 4e has been given to you. So let's replace those 2 values in the curve and find in the equation and find those 2 values. So for the first one here, we have x and y. So ln k, so 1 over k ln 1 minus 2 over root of 1 plus c. Now ln 1 is equal to 0, you can check. So that will become 0. That will be 0 is equal to minus 2 plus c. C will be 2. That is the value of c. Now using that value of c, let's find the value of k, that is x and y. So back to the equation, you will have 1 over k ln y equal to minus 2 over root x plus 2. Now replace this one back in the equation. 1 over k, y is e equal to minus 2 over root of 4 plus 2. That should give you what? Let's see. That should be 1 over k. ln e is just 1 is equal to, this should be minus 2, that should be 2, that should be minus 1 plus 2, that should be 1. So k is equal to 1. Now going back to your equation, you will have ln y is equal to minus 2 over root of x plus 2. So y is equal to exponential minus 2 over root of x plus 2. That will be your answer of y in terms of x. That will be for part A of your question. Now let's move on to part B. Describe what happens to y as x tends to infinity. So as x goes to infinity, if you look at the equation, you will see what happens. This is y e power 2 over root of x plus 2. Now if you observe this, we have minus 2 over root of x. So if x goes to infinity, if x keeps increasing, this value of the function will approach the value of 0. I hope that makes sense. For example, let's say I have 2 on top, divide by 10. Okay, you will have 0.2. Now I have 2 on top, divide by 100. That will be 0.02. 2 divided by, keep increasing, become smaller and smaller. So exactly what happens here, the value goes lower and lower, approaching the value of 0. So this will become 0. So that will be 0 plus 2. Y approaches the value of exponential of 2. So you can write y approaches exponential square. And that will be your answer for part B. And that is your question number 8. Okay, let's move on to question number 9. With respect to the origin O, the vertices of a triangle have 3 vectors. Now part 1, using a scalar product, show that the angle ABC is a right angle. So we have to show that AB dot product BC is equal to 0 because it is a right angle. So what is AB? AB can be found by OB minus OA. That should be this one, 3, 2, 3 minus 2, 0, 5. That will be 1, 2 minus 2. Now what is BC? That will be OC minus OB. OC is 1, 1, 1. OB is 3, 2, 3. That will be minus 2. That will be minus 1 and minus 2. Now we can just solve them and see what happens, right? So do the dot product. First one is this, dot product of this. Let's see what is the answer for this one. So minus 1 times minus 2, sorry, 1 times minus 2 is minus 2, plus 2 times minus 1 is minus 2, plus 4. That is minus 4 plus 4 is equal to 0. This is shown as required. The angle will be 90 degrees. Now for part B, show that the triangle ABC is isosceles. So we have to prove that two sides are the same. So as we have seen, AB is equal to 1, 2, minus 2, and BC is equal to minus 2, minus 1, and minus 2. So let's find the length of AB. You will see it is equal to 1 plus 2 squared is 4. This square will be 4 as well, should be root of 9, which is 3. Now same step, BC, that will be 4 plus 1 plus 4, root of 9, that should be 3. So as you can see, the length of AB is equal to the length of BC. That is why this is shown as required, because the two sides are equal in the triangle, and ABC is isosceles because of that. Now for part C, find the exact length of the perpendicular from O to the line through BC. Now what is the equation of line through BC? So first we have to find the direction of BC. So what is BC? It is OC, as we have seen, it is 1, 1, 1, minus OB. OB is 3, 2, and 3. You will have minus 2, minus 1, and minus 2. Now you can take out the minus, because it is only a direction. Direction is of the line can be just 2, 1, 2. So the minus means only, it means direction, because this is only direction of BC. We have this one for now. For example, right, we can take out the minus, we get this. So let's say now we have BC. This is B, and this is C. Now find the exact length of the perpendicular from O. So let's say what our O is this point, is O, and we have to find the distance. The perpendicular O, let's say this point is P, right? So first thing is, what is the equation of the line BC? So the equation is any point on the line, well, let's choose the point C, because this is simple, 1, 1, 1, and plus direction. So let's choose a multiple times the direction, 2, 1, 2. That is the equation of line BC. Now let's say P is a point on the line BC, where the point O meets the line at right angle. Now what is the point P? The point P can be we don't know the point. Let's say we can choose randomly. It can be 1 plus 2t. This is the direction of the line OP. We're trying to find the point. No, we're trying to find the length, right? We just need to find the normal point first, and then find the length. That will be 1 plus t and 1 plus 2t. That is the direction of the line OP. Now, since this line and this line are in right angle, we know that the dot product has to give you 0. So OP is 1 plus 2t, 1 plus t, and 1 plus this, multiplied by the direction of the line BC, which is this one, 2, 1, 2. That should give you 0 because these two lines are at right angle. So let's solve for the value of t. You will have 2 plus 4t plus 1 plus t plus 2 plus 4t. That is equal to 4 plus 1 plus 4, that is 9t, plus 5 equal to 0. So t is equal to minus 5 over 9. So now using this, let's find the point P. So basically, OP is equal to 1 plus 2 times minus 5 over 9, 1 plus minus 5 over 9, 1 plus 2 times minus 5 over 9. Let's see what we have. That will be minus 1 over 9. We have 1 plus, minus 5 over 9 should be 4 over 9. And the last one is minus 1 over 9 as well. So now we know that OP is equal to this point, OP. So we have to find the length. So pretty easy. The length of OP should be what? We use our formula, that is root of, that'll be 1 over 81 plus 16 over 81 plus 1 over 81. That is 18 over 81 square root. Now you can simplify this. If you divide top bottom by 9, you will have 2 over 9 root, which will be root 2 over 3. That will be your length of the line OP, which is the perpendicular to the line BC. And that will be part C of your question number 9. So let's move on to question number 10. That is your last question of this paper. Now part A, the complex number u is defined by this equation. We have A is a real part. Now part 1, express u as a Cartesian in the form of this. So let's do that. We have u equal to 3i over a plus 2i. Now just like when you work with surds, you know that when you had like 1 plus root 2, for example, you always multiply by the conjugate of the base, right? So same way here, you have to multiply by the conjugate of the base. You will have a minus 2i times a minus 2i. So now if you simplify, that will become 3ai minus 6i squared over, this will become a squared minus 4i squared. Now as you know, I squared is equal to minus 1. Now replace, you will have 3ai plus 6 over a squared plus 4. Now let's rewrite this down in terms of this form, right? where the real part is real. So we have 6 over a squared plus 4, that is your real part, plus your imaginary part. This will be your answer for part 1, where it is you have your imaginary part and your real part. Now for part 2, find the exact value of a if the argument of u, this is the conjugate, is equal to this. So first, what is this? It is equal to 6 over a squared plus 4 has to be minus 3a over a squared plus 4i. Now, how did you find this value? How did we find this value? So we had to do tan inverse of this value, minus 3a over a squared plus 4, divide by this value. So when you divide, you can also multiply, but you have to flip this upside down. It's supposed to give you this value, 1 over 3 pi. Now we can send this one over here. So this one will be cancelled out, as you can see. So you will have minus a over 2 is equal to tan of 1 over 3, this. So what is the value? Tan of 1 over 3 pi. That is root 3. Sorry. Yeah, root 3. So minus a over 2 is equal to root 3. So from this, a is equal to minus 2 root 3. That is your value of a, exact value of a for which this is true. Okay, that will be part 2. Now let's move on to part B. On a sketch of an organ diagram, shade the region whose points represent the complex numbers satisfying these and this inequalities. So the first step is to draw your vertical imaginary axis and your horizontal real axis, right? That's the first step. Label those as real, and this is your imaginary axis. Now so let's draw a scale here so we can have a approximation to where we can plot our values. Okay, that will be this side and this will be. Okay, doesn't need to be exact, it's just a approximation of the scale. So here we have 1, 2, 3, 4. Here we have I, 2i, 3i, and 4i, for example. Now for the first one, as you can see, it says z minus, so the distance from z, from this point of 2i, from this point, and from this one, so when you have to take out minus, you will have z minus bracket 1 plus I. So from this point, 1 plus I will be right here. So it will be the distance. You have to find the perpendicular bisector of these two. So let's draw a line joining those two. So what is the perpendicular bisector that goes through this line? So if you observe, it has to go well. It has to be about this, right? About this point. It is only a sketch, so it doesn't need to be exact. It is only a sketch. Now for this one, as you can see, the distance from z, we have to take out minus, you'll have 2 plus I is less or equal to 2. From this point, 2i is this point. Whenever you see something like this, you have to draw a circle of radius 2 with center 2 plus I. 2 plus I. So radius 2 will be, this will be 2 here. This will be 2 here. This will be 2 here. 2 here. Okay. So let's connect the points. So try your best to make it look like a circle. Even if it's only a sketch, try your best to draw this circle. Okay, so you have this. Okay, so now we have to shade our defined region. As you can see, it has to be inside this circle according to this one, and this one, it says, has to be closer to this point, has to be closer, has to be above. So it will be this region as your shaded region. That will be for part B, part 1. Now for part 2, calculate the least value of argz for the points in this region. So where do you think will be the least value of argz? So as by observation, you will see the point in this region that would have the least arc will be this point. Let's call this point P. And what is the coordinates of this point? If you observe, this is your radius, right? Radius, it is on the circle. Okay, so that will be your point P, which will be 2 and 3i. So to find the argument, pretty easy. Argument of the point P should be tan inverse of 3/2. So we have to use radians. Why not? 3 divided by 2. That should be 0.982 radians. Okay, so by showing this, you can definitely, that is true. And that will be your question for number 10. So that was the last question of this paper. I hope that was somewhat helpful. As always, thank you for watching, and I will see you soon.